All right. So as you can see, I came straight from work in my uniform. And I mean, Brandon already gave this away, but happy birthday to Star Trek. Like, 50 years. There's some Star Wars fans booing? Come on. All the science fiction is good. We like all of it. So, I'm going to talk about the science in Star Trek. And now, putting this talk together, it quickly became very apparent that something that's been going for 50 years has spawned 5 series of television and 13 movies, 9 of which I'm willing to acknowledge exist. If you can guess which 9, I'll buy you a drink. It's very, very difficult to do that any justice in 15 minutes. So we're going to power through, and I'm barely even going to scrape the surface. So if you want to know more, I mean, talk to me anytime. But we're just going to pick out a few of my very favourite points of the science of Star Trek. Now, when I tell people that I'm interested in analysing the science in Star Trek, they all tell me that I'm daft, that it's a complete waste of time, because it's all nonsense like warp drive and transporter beams, right? So I'm going to say up front, I do not care about the big picture, hand-wavy stuff like warp drive and transporter beams. And this is why. Why do we need warp drive? It turns out, and this is something I say over and over again in every single talk I give, space is really, really big. So imagine we want to venture out into the universe. We're going to hear a bit in the next talk about how difficult that is, how long it takes. But you know, the moon and Mars, that's boring, that's been done. Let's try and go to the edge of our solar system. Let's go visit Pluto. Go check out the pretty heart on Pluto. So Pluto, obviously the distance of Pluto changes because we can be on opposite sides of the sun, whatever. But on average, it's about 7 light hours away. That means it's so far away that it takes light 7 hours to get from Pluto to us. And it turns out light travels the fastest anything can go in the universe, according to our understanding of physics. And that's a pretty fundamental rule of physics. You can't just invent better technology to beat it. So even if you could go the fastest it's possible to go, it's going to take you 7 hours to get to Pluto. So that's doable though, right? I mean, it's a 7-hour drive from here out to McDonald Observatory. I do that all the time, it's fine. But Pluto isn't actually very far. If we want to get to the real edge of our solar system, let's say we want to go to the Oort cloud, suddenly we're looking at a day. That's starting to get a bit harder. That's like here to somewhere in Arizona. But even this is only our solar system. There's probably no other intelligent life in our solar system, so we don't really care about that. Let's say we want to go to Vulcan. Vulcan is where the cool aliens live. That's 16 light years away. So even at the speed of light, which we can't even travel that fast, it's going to take 16 years to get to Vulcan. So that's not much fun, hence warp drive. So in the original series of Star Trek, warp drive is just a hand-wavy thing that lets you go faster than light. I'll talk a little bit later on about how it might work, but it doesn't, it's made up. And the rule in the original series is that the speed you're traveling is the speed of light times your warp factor cubed. So say you're going warp 10, because that's math that I can do when I'm on stage, you're going 1,000 times the speed of light, which is pretty fast, but it turns out the galaxy is really, really big. So going to Vulcan, which is actually a pretty nearby planet, at warp 7, which is more like the speeds they tend to go in the series, it's going to take you 17 days. So this was the rule they actually came up with for the original series that was given to writers of episodes. They don't always stick to it. It tends to take as long as the plot requires to get anywhere. But if you're trying to follow the supposed rules, this is the rule. Of course, when they get to Next Generation, they then included a limit at warp 10. So you asymptote, you can't actually get to warp 10. But that was not true in the original series. So let's dive into the original series. This is my favourite, you can probably tell. This is the one that we're celebrating the 50th anniversary of. And I'm going to dive into the pilot episode. This is actually the second pilot. It was not the first episode to air, but it aired 50 years ago this Thursday, so it's pretty timely, and I consider it the first episode because it was a pilot and it has a lot of hallmarks of a pilot. So the pilot episode, Where No Man Has Gone Before, finds us at the edge of the galaxy where we encounter this galactic barrier. So first of all, I have to say I have a problem with being at the edge of the galaxy because galaxies don't really have edges. But setting that aside, galactic barrier. So Spock says something along the lines of sensors can't see anything, which is something that struck me as quite odd, because sensors on the whole tend to detect electromagnetic radiation, i.e. light. And I can tell you just from looking at that image that that thing is emitting electromagnetic radiation somewhere in the optical range of the spectrum. And I can tell you that because I'm fortunate enough to have electromagnetic sensors in my head called eyes. So I'm unclear exactly what their sensors are measuring. I have to tell you this barrier definitely does not exist today. Because my day job, and I'm not talking about Star Trek, is to study distant galaxies. If this was at the edge of our galaxy, we wouldn't be able to see anything outside of it, certainly in the optical range of the spectrum, which would be a problem. I would not be able to do my job. I would not be paying my rent, so that would suck. However, Star Trek does take place 200 years from now, so who knows, maybe some descendant of Donald Trump put up a barrier there. So it's very easy to get very ranty about the science in Star Trek when you're just focusing on the stuff that's relevant to the plot. But the thing I've noticed as I rewatch it is it's not the big plot elements that are interesting scientifically, it's random little throwaway lines. So I want you to listen to this captain's log from this same episode.
Stardate 1313.1. We're now approaching Delta Vega, course set for a standard orbit. This planet, completely uninhabited, is slightly smaller than Earth, desolate but rich in crystal and minerals.
So you're probably thinking, nothing much in that, right? We just came back from commercial break. He's just reminding us where we are, what we're doing. What we're doing is heading to Delta Vega, which is a different Delta Vega to the one that was used later in the movies. It's a mining colony, and they're going to strand Gary Mitchell there, who's developed these scary superpowers. But there's some interesting stuff hidden in that captain's log. He mentions it's a mining planet, obviously, and he mentions that it's smaller than Earth. And this is the reason that's interesting. It's to do with the physics of planet formation. So how you make a planet, how you make a solar system, is you take a gigantic cloud of gas and dust, and this all condenses under gravity, and you get the big central clump at the middle will turn into a star, and other bits on the outside will start to fragment and clump together and form planets. Now, the interesting thing is that this all came from the same cloud of gas and dust to begin with. So the composition is going to be fairly uniform throughout your solar system. However, as this clump condenses into a planet, what happens is the heavy elements will sink to the center. And then eventually the planet cools down, and when it's no longer liquid, stuff can't move around and kind of stays in place. So this is why the Earth has an iron core. Iron is pretty heavy, sinks to the center. However, if your planet is smaller, it cools more quickly. So stuff doesn't have time to sink to the center before the planet cools and solidifies. So your iron, instead of ending up in the core, more of it is going to end up near the surface. So if you look at pictures of Mars, you see that it's red. And anyone know why Mars is red? Yes, I kind of gave it away, but yes, I imagine this crowd would know this anyway. It's iron oxide or rust. So there is a lot more iron on the surface of Mars than there is on Earth because Mars is smaller. And this is why a small planet would actually be a really obvious place to put a mining colony. A lot more heavy elements near the surface where you can reach them. So that's like a really cool bit of science that was just hidden away in a captain's log where most people wouldn't notice it, which was pretty neat. So I'm going to jump forward. As I said, we have to jump a lot to do this in 15 minutes. So let's jump to, this is the episode The Galileo 7. And we're going to talk about things where the writers knew that there were outstanding issues in contemporary astrophysics and actually put this into the episode. So The Galileo 7 is a fantastic episode because it's about Spock. But a lot of people don't remember the setup for the episode, which is this thing. They're investigating this Murasaki effect, which is a quasar, and they have standing orders to investigate all quasars and quasar-like phenomena. Now, in the 1960s, quasars had only just been discovered. They were discovered in the 50s. No one knew what they were. They're really, really weird because they're extremely bright, but they also seem to be very distant. But it wasn't possible for them to be that distant because they were way too bright, and if they were far away as well, then up close they would have to be insanely bright, and that's not possible. Except it turns out it is possible, but no one knew that in the 60s. So hence you have, this is the original version of the episode, this quasar is a vague, fuzzy thing. Now, we now know what quasars are. They're black holes. There's a lot of stuff falling onto the black hole, which is moving very quickly, emitting a lot of radiation. So in the remastered episode, they updated it. And this is what it looks like now. This is actually an accreting black hole, like a quasar, which is pretty cool, except they don't change the dialogue. So Kirk still refers to this as a fuzzy, indistinct thing. And also, there are no quasars in the Milky Way. They're really far away. So I kind of wish they had just left the image as the original, because at least it matched what was going on in the episode. But it's still pretty neat that this is a thing that was a big open question in the 60s, and they actually had the Enterprise investigate it. So jumping again
in
to
this
Balance of
galaxy,
Terror.
there's a mathematical probability of 3 million Earth-type planets. And in all of the universe, 3 million galaxies like this. And in all of that, and perhaps more, only one of each of us.
So this is an awesome episode. It's one of my favourites, and that is one of my favourite scenes in the whole of Star Trek. And the reason is that I like to harp on a lot about how space is really big, and a lot of science fiction does this space is huge thing, and the punchline is usually, so you're really insignificant and you don't matter. And this is one of the few examples where it's the opposite. It's you're really, really tiny compared to the universe, and there is only one of you, and that's why it's important that you do the right thing, which is pretty cool. However, there was numbers in that scene, so obviously I'm going to rip it to shreds. So let's look at the universe according to Dr. McCoy. So the first thing he talks about is 3 million Earth-type planets. Now, what's cool about this is we've only even begun to answer this question, how many Earth-like planets are there in the last decade or so? So obviously, no one knew in the 60s how many there were. We now have this Kepler spacecraft, Kepler Space Telescope, that has found thousands of planets. So we have a much better idea of this now. It turns out we think about 1 in 5 sun-like stars has an Earth-like habitable planet. So they are way more common than we ever thought they were. There are about 20 billion with a B, sun-like stars in our galaxy alone. So about a fifth of them. So you get about 4 billion Earth-type planets, and that's only around sun-like stars. Most of the stars in the galaxy are not like our sun. So that's way, way, way more, many orders of magnitude more than McCoy thought. How about 3 million galaxies? So the best way we can answer this is by looking at one of my favourite images. This is the Hubble Ultra Deep Field. This image here is very, very tiny. If you hold a penny out at arm's length, Lincoln's eye would completely cover that patch of sky, and there are 10,000 galaxies in that patch of sky. So there's a lot of galaxies. It turns out if you extrapolate that across the entire sky, so you assume that's an average bit of universe, you get at least 100 billion. Now, those are only the galaxies Hubble can see, though, and Hubble, although it's awesome and is in space, is actually a pretty small telescope. So check in with us again on that one after the James Webb Space Telescope launches, and maybe we can update that number and get up to 3 million. How about only one of each of us? Well, it's a nice sentiment, but at a quick count, I count duplicate Kirks from transporter accidents, android Kirks, mirror universe counterparts, also now the reboot, and also shapeshifter impersonators, at least 3 off the top of my head. So that one's questionable. Now I'm going to skip way, way, way ahead to Star Trek II, The Wrath of Khan. It is not by accident, I'm skipping 1. Although that's actually one of the movies that I acknowledge exists, it's still not good. Star Trek II, The Wrath of Khan is awesome, and I'm going to talk about this scene.
Trouble with the Nebula, sir, is all that static discharging gas clouds our tactical display. Visual won't function, and shields will be useless.
Sauce for the goose, Mr. Savick. The odds will be even.
I'm going to skip right to the Nebula now.
was slowing. Can't follow them into the nebula, sir. Shields would be useless.
So you can tell both from how, like, the dramatic music, how scared Khan looks there, and also by how much I had to skip, that this is a really big deal going to this nebula, and everyone is very, very scared, and none of their shields or sensors or anything are going to work. Nebulae, they're very pretty. Most of the shiny images you see from the Hubble Space Telescope are nebulae, but they are actually not full of very much stuff. So there's no such thing really as empty space. A vacuum holds about 1 atom in every cubic centimetre. And if you get into a nebula, which is a big cloud of gas and dust, it's about 100,000 times more dense than that. So you think that's pretty dense, right? But it turns out the air you're breathing right now is a quadrillion times more dense than a nebula. So that's a big difference. So you have to believe that the Enterprise's sensors and shields don't work in something that is a quadrillion times less dense than air, even though in Star Trek Into Darkness, which does not exist, I'm sorry, it's true, you see the Enterprise functioning in atmosphere and even water. So, also lightning. Star Trek really likes putting lightning in nebulae. I don't know where that comes from. So that's the one thing I'm going to say about Wrath of Khan. It's an awesome movie. If you like it, or if you are interested in seeing it, if you haven't before, and you want to hear me rant about it, keep an eye on our Facebook page, because we might be doing an event with the Alamo very soon if we can sort out the licensing. So let's skip ahead again. 2016, we're 50 years after the original series. If MC Super Duper had still been here, I would have done the first reboot movie just to talk about the supernova and watch his head explode, but I'm not going to do that. So Star Trek Beyond, who here has seen it? Who here saw it with me? Yay! I actually think this is a great movie. I love it, unexpectedly. But the premise is the same thing. They're really, really scared of going into this nebula, and it has lightning and all these things. And so I decided to see this as a nod to Wrath of Khan rather than any attempt at accurate science, and that makes it a lot more bearable. But there was one thing that was really cool. They're trying to explore this nebula, and they come across these spacecraft, which were uncrewed probes that were sent out to investigate the nebula before they got there, and they're called the Magellan probes, which is a real thing. This was actually the first planetary spacecraft to be launched on the space shuttle. It was launched on the Atlantis on Star Wars Day, May the 4th, 1989, and it went to Venus. There's a picture of the Magellan. And this animation here of... Oh, no, it's not going to animate, okay. Is this picture of Venus uses data from the Magellan probe. It found, amongst other things, that it's covered in volcanoes and all this cool stuff. So that was a really neat little nod to real science. Similar to the way they used to do these things in the original series, which is one of the reasons I liked it. So just to finish, my favourite thing about Star Trek Beyond is this tiny little clip, which I took from the trailer, of when you see the Enterprise at warp. So the way warp drive works, doesn't work. The way it's supposed to work is you're bending space. And it turns out we know space can bend. That's general relativity. It's the whole point of it. When you have mass, it bends space. And when you have bent space, light gets curved. So if you see all this like bendy, twisty light, this is stars behind the Enterprise where the light is being distorted by the curved space. This is gravitational lensing. And the reason I really like this is what I work on. This is my day job. So seeing gravitational lensing in a movie, especially a Star Trek movie, it's pretty dang awesome. This is not actually the only movie recently that has used gravitational lensing. This image of the black hole Gargantua from Interstellar, the big ring of light you see is light behind the black hole that's being lensed by the curved space around the black hole. Which is a cool effect. However, this is the only reason to see that movie. So if you haven't seen it already, there are better things you can do with 3 hours of your life, like watching Wrath of Khan 1.5 times. Anyway, this is all I had time for. If you want more rants about Star Trek and science, you can find me on Tumblr at Snarky Astronomer. And I post most days when people don't steal my hard drives. I'm currently still working on season 1 of the original series and being extremely nitpicky, so it goes slowly. I just want to finish with a quote. There's no such thing as the unknown, only things temporarily hidden, temporarily not understood. So this was said by Captain Kirk in the episode The Corbomite Maneuver, when he's trying to tell his crew to not panic about this scary thing that's about to destroy them. And he also says it again in Star Trek Beyond, which was a nice nod again to the original series. The reason I really like this quote is it sums up Star Trek. The whole point of Star Trek was this utopian idea of the future where everyone gets along. And when you discover something scary that you don't understand, you try to understand it and come to an agreement, and you better yourself and the world by doing that, which I think is not only a great message in Star Trek, it's also kind of what we do with science, like pushing forward our understanding of things, and kind of a story of humanity as well. So this, I think, is why Star Trek has persisted for 50 years and continues to be relevant to so many people, which is awesome. So thank you very much.
All right. MC Heisey, coming home. Great talk. Thank you. All right, questions. Questions from the audience. You see anyone out there? Oh, there we go. In the back, Leon.
The question was, why don't I like Interstellar? Many reasons, but I think its biggest flaw is it's really boring.
I disagree. Okay, in the back.
So, I noticed that you listed a million, and 100 billion. 100 billion in US million would be small. Million would be less than a million.
Okay, so a billion in science, I get mixed up about which one is UK and which one is US, like a lot of things, because I've been here too long now. But in science, whichever one that is, a billion is one with 9 zeros, whereas a million would be one with 12 zeros. So there is another definition of billion that's one with 12 zeros, but that's not the one we use in science. Sorry, that was confusing. Yeah, so 9 zeros is the one I mean when I say billion. No, I said that's less. Yeah, sorry, I wasn't clear. McCoy thought there were more galaxies than we think there are, but we haven't seen all the galaxies, so.
So, like you said, stay tuned. James Webb will hopefully open that up right back there.
How did Scotty teleport during warp?
I'm sorry, I couldn't hear the actual question over the laughter. Okay, so teleportation was another thing that I skipped over. There is actually mention of it in The Squire of Gothos, another season 1 episode where they try to explain how it works. And the way it's supposed to work is you take matter, you convert it into energy, and then you reverse that process somewhere else, which is theoretically possible. Depending on who you talk to, you can either convert between mass and energy, or they're the same thing anyway. The way I like to think about it is you're essentially just reading the position and momentum of every particle in someone's body and then recreating that body somewhere else. The big problem with that is you actually cannot measure position and momentum of particles that accurately because of the Heisenberg uncertainty principle, which is why in Star Trek they have Heisenberg compensators, so problem solved.
All right, last question right here up front.
So how do you feel about hard science fiction where you have to obey the laws of physics that we currently understand and still tell a good story?
So the question was, how do I feel about hard science fiction where you have to obey the laws of physics and still tell a good story? The answer is, if the story is good, I love it. I care more about the story, as much fun as picking the science apart is. So The Martian was reasonably accurate science and an awesome book and movie. However, if you're going to obey the laws of physics, you can't visit a planet every week. So I'm willing to bend them for a good story.
Okay, I got some boos when I said that was the last question. Does someone want to ask one more? All right, right here.
Okay, I don't know if that's a question or a comment, but there was a thing in the news apparently recently that they managed to make transparent, I'm going to say aluminium. I actually didn't read that. If so, that's awesome. But we should have it already because we already know that Scotty went back in time and sold transparent aluminium to San Francisco in the 1980s. So it's about time, really, that they discover it.
All right, let's thank MC Heisey one more time.